Good evening, everyone, and welcome to this month's edition of the Iowa Pork Industry Center monthly webinar series. This month, we're going to talk about swine health, and more specifically, we're going to talk about PRRS. We're very fortunate to have a couple of internal experts from Iowa State University here to talk about their work in PRRS, which is very timely as the weather now is starting to get colder. A lot of pits are getting pumped. This is the time of year that we start to see a little bit more PRRS activity. So with us tonight, we have Dr. Daniel Linhares. Daniel's an associate professor and the holder of the Roy A. Schultz Professorship in Swine Medicine over at the College of Veterinary Medicine, as well as Dr. Giovanni Trevisan, who's an assistant professor at the Veterinary Diagnostic Lab over at the College of Veterinary Medicine. So Daniel's going to talk to us tonight about some monitoring methods for breeding herds. And Giovanni, as he's we call him the godfather of next generation sequencing. So he's going to talk about using some of those tools. So because of that, we kind of refer to him lovingly as the Don. So we'll hear from Don Giovanni second. We'll listen to Daniel first. So with that, Daniel, you can go ahead and take it away.
All right. Thank you very much, Chris, for the introduction. I can't wait to hear the Dawn. So I'll keep it short and sweet. I appreciate the invitation to join the webinar here today. For those live or later, if you were watching recorded, please do not hesitate to come and ask any of us here any follow-up, comment, question, feedback that you may have. Quick introduction here from the team. The stuff I'm gonna present about is from our team. We call ourselves the Field Pit Team at Iowa State. We're housed in the VDPM department and the College of Veterinary Medicine. And long story short, we're a group of 23 people that are focused on field research, field-based research, working directly with swine veterinarians and producers for research. And so here we are going to summarize our findings, like Chris said, on what's new on PRRS monitoring, specifically in breeding herds. Talking about why we're talking about this, why did we select this in the recent years, maybe the last 5 to 10 years, there has been a lot of developments of new sampling approaches, including diagnostic testing. And you can see we're going to talk more about that later, but tongue tissue fluids, processing fluids, family oral fluids, and in addition to serum. And of course, there is also a growing interest in the use of ongoing monitoring of production data. So the diagnostic testing is really good, sensitive, specific, but of course, people don't test that every day or every other day. But the productivity data, things like aborts, mortalities, that's recorded every day. So why not take advantage of that for daily monitoring for signals? And the other thing that's on the rise as we speak is the sensor-based technology to look at pigs in terms of pig populations, in terms of sound that may indicate cough, or video camera based. Those are still evolving as we speak, but that's coming shortly at us, which is exciting. And for all of those sample types, if you haven't seen this website, I would certainly encourage you to visit securepork.org/CSSC, and that stands for Certified Swine Sampler Collector, which is a really nice compilation of sample types here, put together by Dr. Justin Brown and team. And he has a collection of quick videos. It's 1 to 2 minute videos, so really good to bring that to the field and show farm staff. And accompanying those videos, there are quick fact sheets in English and Spanish on one page, really simple, on how to collect, how to accommodate for transport and handling to the VDL for testing. So a lot of good material there to train on-farm people on how to collect the various sample types from serum to those population-based ones that we talked about. So really good resource for you if you're not familiar with that yet. And regardless of the sample type, one thing that we like to encourage people to do is when the breeding herds go through an outbreak of PRRS virus, we encourage people to start testing and monitoring as soon as possible after the outbreak. Certainly the first few weeks are going to be very positive, so no need over there, but sometime after week 10, 8, 10, 12, it's a good practice to start monitoring. You still expect positive result, but what you expect to see is a trend of raising CT values toward negativity, right? As a reminder, the higher the CT for PCR testing, the less virus there is in the sample. So what you expect is start with low CT and then go to CTs will go toward the cutoff to be determined as negative, which is for most PCR tests at 37 or 40. So encourage people to monitor early, so they make sure that they're trending toward negativity. And so if they are not, there will be actions that can be implemented at that time. And we also like to remind people, before we talk more about sample types, that a series of studies done by Dr. Marcelo Almeida, which was part of the FieldEpi, now he's a diagnostician at the Ohio State VDL. He did a whole PhD around this area where he's sampled several crates, several pigs, several rooms in multiple farms. And what you see here in the screen is a snapshot of one herd at the same day. So this is one herd, rooms 1, 2, 3, 4. Those are all farrowing rooms where he sampled with family oral fluids every crate. Again, same day. Those rooms were all from pigs really close to weaning age, so around 20 days or so. And blue means tested negative by PCR, red is positive by PCR, and you can see that rooms 1 and 2, there was no evidence of PRRS virus. Room 3, about 50% of the crates were positive, and room 4 was loaded with virus, right, with a lot of reds, a lot of PCR positive liters. So just demonstrating the importance for when you are sampling for PRRS virus to sample multiple rooms, and so the danger to extrapolate results from one room to the next, because they may or may not have the same result. And also implications for when you're, especially when you are toward the end of elimination practices and you're approaching that stable or negative status, is you don't want to be moving pigs across rooms. Maybe if you really have to move pigs, it would be try to do that within rooms, but not across rooms. Well, and now going a little bit deeper here, now each square is an individual pig. Marcelo bled those pigs individually and tested individually by PCR, and it's the same deal where the red is PCR positive, blue is PCR negative, and what you see here is that even within positive rooms, the virus is not randomly or it's spread out across, scattered across the pigs and rooms. They're really clustered in a few crates, and even with the positive crates, some pigs may be positive, the others may be negative. So again, demonstrating the implication of this is demonstrating the importance of hitting multiple crates when we're sampling pigs, right? They're not sampling every pig in a couple of crates and moving on. Those crates that are positive, they are the two risk factors that we found was gilt litters and litters with a relatively small number of piglets. And so when we're sampling, just not sample at random, right? You have a few crates or pigs to choose from. Would start from those from the gilt litters the parity one sows, right? And then the litters with a relatively small number of piglets compared to the rest of the room. Those will be your risk-based samples to increase the chance of finding the virus with the budget you have for testing. And here more of the same. This slide what shows is sampling either by processing fluids or family or fluids over time. And it's the same concept where you have some rooms and some days, some weeks that are positive. And then at some point in time after when prevalence is reaching a low, you will find some negative ones, but it's still a good sign when the herd has a negative result. But then to really call the herd as stable and gain confidence that the wild type is gone, so you can bring in negative gilts again if that's the plan, you really need a stretch of time to be considered negative, because it's pretty common that you have some weeks negative and then a few positive, and that's when the prevalence is reaching that near zero prevalence. So the current American Association of Swine Practitioners recommendation by Dr. Holtkamp to call a herd as stable is you really need to reach 13 consecutive weeks of negative at the winning age piglet population to gain confidence that the virus is gone from the herd. So how do we put that together, those different sample types, based on what we have so far in terms of results for the different studies on those different sample types? Is we believe for herds that are undergoing stability or elimination, processing fluid is still the best choice to do weekly testing. So we would recommend collecting samples from all the piglets that are processed in the whole week, right? Don't select just a few rooms. Don't select just a few crates, because you saw the reason why the virus is maybe in some places but not in others. So you collect all the piglets that are being processed that week. You store that in the freezer or refrigerator and send for a one massive pool per week. Just one PCR per week, but considering everybody there. If you don't do physical castration, the tongue tips from all the piglets that died during the first week are a very good alternative to that. So we would keep doing this massive PCR per week. If the results are expected because it's early after the break, you keep monitoring, keep rolling in this cycle here until the results are negative. If they're not negative, if they are positive but not expected because it's too long after the outbreak, say it's 26 weeks and the CTs are still low or a lot of virus being detected, then you may want to ask yourself, where is this virus coming from? Is it from the breeding herd? And so the breeding herd is still positive, the gestating sows are positive and giving birth to negative pigs? Or are the piglets being born negative but then getting infected after they're born, right? We call that horizontal transmission. And if you collect stillborn tongue tips and then send those fluids for PCR testing, if they're positive, then our interpretation is that the gestating cells are still positive. So we need to focus here on boosting herd immunity or waiting more time for that protective immunity to develop. When the tongue tip or stillborn PCRs are negative, but your processing fluids are still negative, the interpretation is that, well, the cells are negative, but then the piglets are getting infected after they are born with everything. There's a lot of intense movement between pigs and during processing, right? And moving pigs around. So a lot of stuff that's going on in that first week. So applying some strict biomanagement to keep pigs negative is something to consider. So you keep doing that until you start having negative result. Remember that our recommendation was one massive pool for one PCR per week, regardless of the herd size. When those are negative for a few weeks, that's when we start opening the pools. And we recommend you can still pool aggressively. Processing fluid is very sensitive because the PCR amplifies those few negatives in the few positives in the sample. but you can pull all the way to 50, 60, 50 to 60 grades per processing fluid, still good. When you have a stretch of 3, 4, 5 weeks of negative, consistently negative result, with that, it's time to check the winners. One way to do that is family oral fluids at farrowing, or oral fluid at weaning if you have that unidirectional flow. If they're negative, if the weaning age piglet population is negative, that's what you want, that's great. And as I said before, the herd can be declared stable as soon as you get 13 consecutive weeks of negative results. If those are still positive, family or the weaning age piglet population positive when processing fluid are consistently negative, what does that mean? Well, the answer here is going to be simple. It's pigs are getting infected after that processing time, so opportunity here for strict biomanagement to keep them negative. And we also would recommend to do whole genome sequencing in all the outbreaks, so that when you have those unexpected positive results, you answer the question: did the virus change on you? Is it a recombination, or is it an unrelated virus introduction? And Giovanni is gonna walk through that in more detail in a bit. One last thing here, little quick to wrap up. I'm talking about the importance of hitting several crates, several rooms, and doing that over time. And then you may want to ask, hey, you're asking to do a lot of PCRs. Can I aggregate those? Can I pull those samples so that uh, uh, the monitoring is still cost effective? And we like to bring this example of a scenario which is pretty common. Let's say you put your own number here, but let's say that in this scenario is you have a budget to cover 3 PCRs for that week. And then you using family oral fluids, for example, in this farrowing room of 60 crates, which one is the best option for you? If your budget is 3 PCRs, the first option is you're not going to pull, you're going to select 3 crates, and there you go with your 3 PCRs. If you pull, in this example here, doing pulls of 5, then this is the other scenario. Note that you're going from 3 PCRs individually versus 3 PCRs in pools of 5. And the option B is gonna give you a greater coverage, but at the same time, you're potentially diluting more the positive result at low prevalence. And that's true. Those two things happen at the same time. In one hand, the more we pull, the more we dilute. So you think about the dilution effect, but at the same time, the more you pull, if you have that fixed budget, the more chance you have to hit those few positive grades. And here is, if you want more of that, there, Henry, who we had in the picture there, did his PhD all around this math about sampling. And here is a table that summarizes that scenario of 3 PCRs. Here in blue, it's showing the probability of sampling the litter. It's not about the dilution effect yet. It's just about the probability of landing in the few positive grades. And the very first number here is if you have just only one positive grade out of 60, and you have 3 individual PCR. If you divide 3 by 60, right, and add the percentage is 5, and that's not it. And so 5% is your probability of landing in that one positive grade. So it's not very good. There are 2 ways to bring this number up. One is to increase the prevalence in the farm, which you don't want. Of course, the higher the prevalence, the higher probability of finding the virus with 3 samples. Or the other way, to the right here, if you go from the left column to the right one, is instead of the 3 samples, now you take 9, or take 15, take 30, take 60. Then, of course, now you substantially increase your probability of landing in the positive one. So Now the second part of the table is the dilution effect. And you see that in the first column, the blue and the green numbers are going to be exactly the same because we're not diluting. And the more you move to the right, the more those numbers are going to be separate because now we're putting the dilution effect on the table. But still, the more you move to the right, all the way to pools of 20 samples, that's where Henry took. He didn't dilute more than that. You go from 5% all the way to 81 when you pull more with that fixed example of 3 PCRs per week. So the take-home message will be: do not be afraid to pull all the way from 1 to 20 with the fluids, right? With the family oral fluids. That will be the take-home. Why? Because of the increased coverage that allows you, which will increase the probability of detection beyond the dilution effect. So to help people with that, Henry and Swami and Mafalda, also they are all from the field epi team. They put together this calculator where in this page there will be several calculators. One of them is this family oral fluids pooling, and so you can plug in your own numbers. How many crates you have? What's the prevalence? So in this case, 5 out of 60, so around 8% or so. And scenario A and B, the same thing here. The only difference that scenario B do pools of 5 and scenario A doesn't do any pooling. You just test the 5 samples you collected, and then the calculator is going to give you the probability of detection considering those two things, right? The increased coverage and the dilution effect. And in this situation here, goes from 36% chance of detecting to 93 when you do pools of 5. All right, so with that, just wanted to put this in front of you to start the discussion, but handing over to you, Chris, so we can keep the discussion going. And I'm not sure if the Q&A is going to be, I guess at the end.
We'll hold them to the end, but yeah, thank you very
Yeah.
much, Daniel. While Giovanni's getting his presentation pulled up,
Very
just
nice.
a reminder, I know that Stacy put a note in the chat for those of you attending live. You can go ahead and go ahead and put any questions for either Daniel or Giovanni in the chat. And when Giovanni gets finished up, we'll go ahead and get to those questions and ask our two panelists those questions that you guys have during the presentation. So yeah, Daniel did a really nice overview of all the different testing and monitoring methods, and now Giovanni's going to share a little bit more of some of the current status of that, and he'll talk a little bit more about the whole genome sequencing as well. So with that, Giovanni, I'll take it away.
Can you hear me, Chris? Just a sound check here.
Yep, we got you.
Yeah, so thank you very much for the opportunity to be here today and talk about what is the current status of PRRS in the field. And after Daniel explain all about how you collect samples and test and the approach for monitoring, now it's time to understand the overall picture of how PRRS is occurring in the field. So thank you for the opportunity. Thank you for the introduction before, Chris. Let me see if I can make this work here nicely. Okay, so looks like here we go. We're going to talk a little bit about the status of the breeding herds according to MSHIM, detection of PRRS according to the SDRS, and the whole genome sequencing approach that Daniel mentioned before. So starting about what's the current status of PRRS according to MSHIM, we have this chart that comes from the Models on Swine Health Monitoring Project that is housed at University of Minnesota. And what presents here is what's the status of the breeding herds according to the PRRS virus that is there present, and you have more than 10 years of information here. The first thing that we can see is, well, there is a group of the breeding herds that they are positive unstable. That means they are sending pigs downstream that they are positive for PRRS. And if you look that over years, we have a trend of increase in the positive herds that we have out there. So about 15% increase from a decade ago, that was about 15%. Now it's about 33-34% of those breeding herds are positive for parasites. What that means is that this has been helping to keep the circulation of parasites in breeding herd, but also the downstream piglets are more positive for parasites. The same on the other direction there, we had more naive herds about a decade ago, that was about 50%, and now we have about 49% of the herds that's still naive for parasites. So that means more herds are keeping positive either by active wild type exposure or by vaccination that's occurring. So overall, more breeding herds are dealing with more parasites. So when we look for the detection of parasites, how that's occurring, we're going to use here information from the swine disease reporting system. And the swine disease reporting system is a project where it receives all anonymized data from the VDLs about what has been tested and how was detected the pathogens. So there are 6 VDLs that share anonymous data with us, no producer, no veterinarian, no information is being shared with us about who is sending the samples. Just the test result, and look for that in terms of identify trends and monitor those trends over time. We also run information for advisory group, and that information comes back in the format of the reports. So if you have not been receiving those reports, you can sign up for those. They are for free. We do not have charge for those, but they provide information about the detection trends of different pathogens. And today we are focusing on PRRS virus here in information. And just to show you who are our advisory group, we have a couple of veterinarians and producers that are members of this advisory group that you may be aware of who they are and who they work for. That also provides this field perspective of what's going on in the field in terms of agent detection coupled with this VDL data that's incorporated in the final report. So looking for PRRS virus, what we have is, well, basically about 7,000 cases are tested for PRRS virus every month in the United States from this network of laboratories information here. So that has been keeping very consistent over the time there. And one of the things that we do in the background of the project is we do monitor the detection of this PRRS virus information. So here we have percentage of positive case. That means how much is cases are positives over the total tested. These red lines represent what occurred. The blue line represents what is expected by a model, and is organized by year and week. The first thing that was different in 2023 was that during summer months, we have lower detection of PRRS virus. It was lower than the previous years, was below the expected there. But surprisingly, after week 42, we had this huge increase in detection of PRRS virus that was, in the beginning was around week 40, was about 18%. Now it's 32% of the cases are positive for PRRS virus. So this step change in detection of PRRS virus is something that concerns us at this time of the year because we are going to the colder months. And when you think about detection in the colder months, we're going to switch gears a little bit to look into the information about different age groups and the implication that it has for detection of PRRS virus. So this chart is organized by year and month, and is detection of PRRS virus, the percentage of positive for different farm types there. If you look, there is kind of waves in those lines that goes up around the month 10, 11, 12, that's October to December, and then goes down month 7 and 6, 8, that is June, July, and August. That means we have the seasonal component of detection of PRRS virus that's increased at the end of the year. And if you look for specific for 2023, there is this increase in detection that is occurring and more significantly in this red line that is the win to market age category. When you look for detection of PRRS virus and look for the different farm types, the win to market has higher positivity than the adult sow farm. And that has been consistently over years and years. And here is represented by this square with the red line in the middle, the triangle shapes there. So this means and implies that win to market has an important role in the detection of PRRS virus over the time. When you look for specifically the second half of the year, and 2023 is not different, there is an increase in detection of PRRS virus that occur first in this win to market age category that includes both nursery and growing sites. And that precedes in about a month the detection of parasitoids increasing in breeding herds. So not different in 2023, that detection is going up pretty fast. If you had a lower detection in the beginning of the year, now that is increasing again. So when to market, nursery and finishing sites play a major role in the detection of parasitoids across the production sites. Well, here we have a chart that what we saw for PRRS, this high activity in the winter market, is also seen for PD, for influenza, and for Delta coronavirus. So it's important to always keep in mind biosecurity practices to keep the disease out of your farm, like shower in, shower out, change boots, but also measures to do biocontainment, that's keeping the disease within your farm and not spread to the other farms that you can have approach that to not leaving the farm with clothes that are from the farm, change the shoes when you're going out. Those are type of procedures that can help to contain the spread of disease. So those are detections and dynamics of this going on. And just out of curiosity, what's the sample type that has been used for parasite testing? Well, just some images here to show what I'm talking about. Oral fluid is the sample type that you collect from the rope in the barns that you hang, the pigs chew on and they collect that as sample type. There is a variation of that is called the family oral fluids, that is the sow and the piglets chew on the rope and you collect that sample there. That's what we call the family oral fluid samples. And there is also the processing fluid samples that is collected from testicles and tails during castration time. So why I'm showing that is because if you look for sample types that are being used in 2023 for parasite testing, we have about 43% that comes from oral fluid samples and the other 16% that are processed fluid samples. So 2/3 of the parasite testing is done from this sample type that's collected. When you look specifically for breeding herds, then the processed fluid samples represents about 3/3 of this sample types used to monitor parasitoids in breeding herds. So they are very significant and play a major role in terms of parasitoids monitoring this population sample based as processed fluid samples and oral fluid samples. So that's the overall detection is going up. It's increasing now at the end of the year. And one thing that we hear a lot about parasitoids is about lineage and RFLP system classification there. So when we look for the trends of detections in terms of parasite sequencing, this chart represents the number of sequences that comes for the SDRS over year and time, and the one on the top represents the percentage of those different lineages of parasite strain. If you look for that, there is one that is highlighted, that is lineage 1C.5, that's also known as lineage 1C variant, that currently in 2023 represents about 30% of all sequences being done for parasitoids. So it's the one that is most frequently detected there as the wild type strain. And if you look for that and try to understand how is the detection across different regions, what we have here is that same chart that is breaking the different parasitoids classified according to lineage and their FLPs by year from 2020 and 23. And you can see that the most frequent detected in the last 3 years is this lineage 1C variant, but we also break down that detection in 2023 for different states. If you look for Iowa as an example, the lineage 1C variant 144 is the most frequent detected, followed by the lineage 184, followed by lineage 18174. So that is that's an example of what's been detected in Iowa. But if you look for Illinois example, the most frequent detected is a lineage 18174. So there is a lot of difference in terms of parasite genetic sequencing recovered across different regions. And you also expect that the clinical presentation of those strains are going to be different across different regions that as you can expect it. So this lineage 1C variant or 1.5 strain, if you look for this image, it's an experimental study that was done by Dr. Zhang at Iowa State University that they infected piglets with different parasite strain. And if you look for the lower right corners, you have piglets that was infected by lineage 144 L1C variant. and 174 lineage 1A. And you can see that those piglets are really are being affected and are down compared to the others and suffering from that infection. So after that, what he did is, well, how can the PRRS MLV vaccines being used to prevent the infection of these, to reduce the clinical signs of this strain, the lineage 1 C.5 or the 1C variant? So he presented this information for different vaccines. He used letters there for classify them. But at the end of the day, he found out that across the 6 MLV vaccines that we have in the market today, 4 of those had one or no mortality across 10 piglets that were infected with this strain. The other 2 had higher mortality compared with these ones. So it's always good to discuss with a veterinarian that provides service to you about how can you use and what vaccine use for control PRRS in your herd. So this is about the 1C variant. The other type of information that is available is through the Iowa State University Veterinary Diagnostic Laboratory. And here we are flipping gears from detection by PCR, but looking for disease diagnosis in tissue samples. That means if you submit lung, brain, those type of things to do a diagnosis, how frequent is disease diagnosis there? And about 25% of the time, PRRS virus has been diagnosed as the most frequent disease in this tissue case at Iowa State University during the last October and November, the last 2 months there. So it's an important disease that we have out there. And this chart is just breaking out that information from 2022 to 2023, the number of PRRS virus cases diagnosed from tissue case at ICU VDL per week. What we have there is there is a line that monitors what is above expected there, and when you have those triangles in the x-axis, that means we are having more detection. But if you look first thing at similar time between 2022 and 2023, that is this red line over here, you can see that around August, the number of PRRS virus cases started to go up last year. In this year, 2023, they continues to be in lower number of cases detected. So when you look for the similar time of this year in terms of number of cases being occurring, now at the very end of October and beginning of January, we had about 60 cases per week that were diagnosed as PRRS. Last year, this was above 100 cases. So this tells us that we are having less activity and less diseases for PRRS virus being occurring in the field. What is a good sign? But we cannot forget that there is one thing that we need to look at, that is how is the disease diagnosed across different age categories, regions, and in terms of week. When we break out this disease diagnosis from January to August, using Iowa State University Veterinary Diagnostic Laboratory data, we could see that the phase of production that had most diagnosis of PRRS virus was from nursery piglets. 821 diagnosed from nursery versus 681 from growing piglets. Most of cases came from Iowa, North Carolina, and this age distribution was basically nursery piglets was the one that was most frequent there. Now, when we break the same information from September to November, we see that there was a flip in the switch there. The growing finishing sites was the phase of production with highest number of diagnoses, 305 versus 238 from nursery. Most of the case comes from Iowa, but you can see that there was this distribution in terms of age that was more towards about 15 weeks. There was a lot of case there. So there was this more diagnosis through the middle to the end of finishing that is occurring. So more activity in growing finishing sites of PRRS virus. Another thing that we need to keep in mind, and this is a chart that has all the major respiratory agents that are listed, is that PRRS virus we think as one single disease, but most of the time it comes with lots of different pathogens that occur together. So keep in mind secondary agents, and treatment for those is very important during the clinical outbreak of PRRS virus, and always good to talk with your vet about that. So the last thing that we are going to talk here about is about using PRRS-wise next generation sequencing results there. And you ask, what is that? So when we do a sequence of PRRS-wise, we basically do a sequence of a gene that's called OR5. That's a 4% of the genome. From that, we call this PRRS-wise sequence according to the FLPs, 174, 184, 144, you name, and lineage 1A, 1H, whatever that you want to know. And we say that about when they are close related, 1 or 2%, we say that is the same strain, but more than that is signals different strain. But that doesn't represent our history of PRRS. When we go for the whole genome, there is other characteristics that we can understand in terms of the evolution, recombination, and mutations that occur in the PRRS. And that provides a better insight of what's going on in terms of this disease in the field. So if you are looking forward to use the whole genome, what you need to have is a farm reference strain. You need to know what's in your farm to be able to do the comparison later on. So what we have been advising is do a sequence at the time of the outbreak, or if you don't have funds, you can store a sample at long-term storage that in the future you can use that to do a sequence in that one. Look for lung or serum with low CT values lower than 22. You had better chance of getting a whole genome recovered. Processing fluid samples is a population-based sample. You look for whole genome, but you can get only partial genomes there. But that is helpful to understand if there is multiple strains circulating in the farm. So as example, here we have an image, and what we have here, you can see that there is 3 colors. One is green, yellow, and red. Each of those colors, they represent one different PRRS strain that was in that sample. So in this sample, there was 2 wild-type strains plus a vaccine strain that was there listed. Another image here that we have, it's very similar, but you have this green full line there that we were able to recover a whole genome from one strain that was present in the sample, and another that was in red and this yellowish with number on tops that represents the second wild-type strain that was there present. So these type of events are very common to occur, and we are being able today of detecting those things. Another thing that we can do is look for recombination when we have the full genome. And recombination means 2 strains, they change genetic material and produce a third one that is very different there. So what we have found in terms of production data is both presence of multiple strains, more than 2 strains in the farm, or farms that went through outbreak of recombining strain, they had higher pig mortality, higher pig loss compared with farms that had less than 2 PRRS strains or not recombined detection in these strains there. So what you can do here is, in terms of next generation sequence, it helps to compare within farms, how is the PRRS detecting over time, identify multiple strains that are circulating. One important piece is screen the LVI samples to see if you don't have one single strain or you have multiple strains that you are injecting in the herd. In those cases where you are following a herd through the outbreak and now start to have more clinical signs or drop in cities, maybe opportunity there to do a next generation sequence and understand if something changed in these virus that is coming to fruition there and providing that outbreak. So a potential approach to use that is, at the time of outbreak, look for having this whole genome recover and or restore the sample that you can be used later on. But in the future, you don't need to use next generation all the time, do a whole genome sequence there. What you can do is, if there is an increase in aborts, piglet mortality, drop in CT values, you ask that question. If that's not occurring, you don't need to go for a whole genome sequence. Now, if that's occurring and you have this farm reference strain to compare, you can do a whole genome sequencing. If you're looking to understand if that strain evolved over time, now you're looking for individual samples like lung, serum, low CT values, and you recover your whole genome that you can do that process of understanding. If you are looking to understand if there is more than one strain circulating in the farm, now you look for process fluid samples or fluid samples, and from that you target the whole genome sequencing. And from that you can compare and understand if there is more than one strain there circulating in the farm. So that was what I had here for today. Thank you very much for the opportunity, and happy to take any questions here.
All right, Giovanni, much appreciated, and Daniel as well for all that excellent information packed into that. We have had a couple of questions come in here, so I'll go ahead and just read them to you. Daniel, I think the first one is for you. You did mention as you were going through your algorithm, you talked about 13 weeks of negative samples to say a farm is considered to be stable or negative. Could you kind of talk through that process and what sample types you could use in order to hit that metric? Oh, Daniel, you're still muted yet, Daniel, I think.
All right, somebody has
No,
to
I
do
got
that,
you.
right? At least
You're
once in
good.
every meeting. So, okay, I got it. So, yeah, I think very nice. I was exchanging some chat here messages with Matt. I think that the take home is that based on the AASV guidelines, the herd should provide evidence of 13 or so, which is 90 days, more or less, right? 3 months of negative results of in that winning age piglet population. Now, how you're gonna do that? It could be with family oral fluids. It could be with serum. However you do it, just it's gotta consider that if the virus is still there when processing fluids are negative and now you're going to the winners, prevalence is gonna be low. The virus is still there, prevalence is gonna be low. So gotta be using at least 60 for a bare minimum 60 ideally. It's more than 100 piglets to provide you confidence to detect at a very low prevalence, and that's why we kind of prefer the population based, either family oral fluids in the farrowing house or oral fluids down the road, downstream, because some 10 family oral fluids have similar probability of detection than 90 or 100 serum samples, more or less. So the key there is document that they're negative for 90 days.
Very good. And maybe just a little bit of a follow-up one. I know tongue tip fluids, Daniel, are kind of a newer sample type. And, we've been using family oral fluids and processing fluids for a longer time period. What advice would you give to producers to thinking about when and how they might use tongue tip fluids if they're already using processing fluids on their farms? When would they kind of use
Uh-huh.
that maybe as an augmentation to the processing fluids?
Right. If they're already using processing fluids and that's working, I would keep using processing fluids. So the tongue tips are a very good alternative to processing fluid, but you don't need to change. The place where we would place it is if processing fluid is positive for way too long, or if the CTs are going down and you wonder where this virus coming from. So at that point in time, you would collect tongue tips specifically from the stillborn population, right? And then compare that with your processing fluid. And if the tongue tips from the stillborns are positive, then you know it's coming from the sow. So the sow herd is still actively shedding virus. If it's negative, you know that that's not the issue. The issue is with internal biomanagement after the pigs are born.
Yeah, so it's more of a lateral contamination within the farrowing room sort of situation in that
Right.
case. Yep.
But if
Okay.
processing fluids, like you said, it's up and running and it's on people on the farm are already comfortable working, I would still use that as as a screening method because it's very sensitive. We know that.
Okay. And then you did mention something about processing fluids testing one sample per week and independent of the farm size. So you don't test multiple bags or you don't have pooling guidelines around that. You're just pooling the processing fluids from the entire week of farrowing into one sample. Is that kind of the current guidelines on that?
Right, because that way you have a really high coverage, right? So you're testing with one PCR hundreds, sometimes thousands of pigs, but you're covering all the rooms. So the few positives that may be there, PCR is gonna amplify that and detect. So you still do that until you're negative, and after you have a few weeks of negative results, then you start worrying, is this negative because the virus is gone or because I'm over diluting? And then that's where you reduce the pooling to 1 for 50 to 60 crates at you don't need to dilute more than that.
Okay, very good. Thank you. Giovanni, I do have a couple of questions for you. So one of those you kind of mentioned, you talked a little bit about some lineages, and then I know we've been using RFLPs for a really long time period. Could you talk to us a little bit about what some of the differences are between those, and maybe introduce the lineage concept and what's kind of the best way to utilize those when we're talking about strains?
Yep. So that's a good question. We are very used with LFLPs that has been used for a long time, but they do not group the sequence together as we expected. For some case like the 174, the lineage 1A, that's very consistent and most of the time that's accurate. But for others, that's not the case. So when you think about lineage, it's like if you have a basket full of different fruits there, that's orange, apples, peaches, and now you have a lineage. Lineage is going to tell you, oh, when you have the same name as lineage 1A and you compare that is your orange, you know that they group together because they are similar. That's what the lineage is trying to do, is try to group the sequence that are more genetic similar in the same bucket as the others. That doesn't mean that they are completely equal because you're looking for only the R5 sequence there.
Okay, very good. That helps. One thing I noticed just in looking at your data when you were comparing the PRRS positivity, kind of early in the year, it was more in the nurseries, and then later in the year, more recently, it was the positivity and grow finish was more in the finisher phase. Do you have any reasons why you think that might be?
Well, there is a lot of discussion lately that we do a lot of pumping in this time of the year that could be igniting the circulation of the virus in these sites, and also there is a lot of rotation of people that move site to site to do the chores. So if one gets infected, now if you don't do biocontain measures to keep parasites inside of that site, you may be spreading that and start to create this bubble of activity in the field. Additional to that is the time of the year that the temperature starts to change, and if you don't control environment well, you can start to let the animals a little bit more comfortable and more susceptible to disease. So those are factors that may be affecting this high activity of parasites at the end of the year.
Yeah, that certainly would make a lot of sense on that for sure. Just checking the chat here, if there's any other ones.
I think Matt Ackerman had another one.
Yeah, so talked about, since we're recording it, everybody can't see what's in the chat. So we did talk about the whole genome sequencing, and I know with that one in particular, you tend to need to have more virus than even a PCR. So can you kind of give some guidelines about that, and what do you do? You know, what's the CT threshold that you need, kind of depending on the different sample types, and what are some things you can do if you have a higher CT and you want to still try to do whole genome sequencing? What are some things that you can attempt to try?
So that's a good question. The first is it's a new tool that you have in the toolbox. Now we have better capabilities of analyzing that information, take information out. So as we progress in that, we understood that if you want to do a next generation sequence, that's what you ask for the video to do. It's like your PCR. You ask for that test, and if you are very successful, you get a whole genome recovered. But you cannot have that success and get a genome fragments that we call the contigs there, that both of them is your positivity and CT values. So next generation sequencing is your PCR, a whole genome, or a contigs is your CT value. If you have a high virus concentration, it's very likely that you have a whole genome that's low CTs, as example, and contigs you get for high CTs. So you need to keep in mind when you're using that tool that these sample types with OCTs are preferable if you want to recover a whole genome sequence there. And that you can use to do analysis if the strain evolved, if there was recombination that affects the productivity of herd. But now, if you look for, well, I do have a farm reference strain that I recover at some time. I'm seeing clinical problems. For example, I'm going towards a elimination process, and let's say week 25 or 30, you have a drop in CT values on your monitoring sample, and you start to see some clinical signs. How can you sort that out? So you can do a next generation sequence individual samples to get a full genome and compare, see if there was genetic evolution, or you can use from a population sampling based as a process field samples. Usually, if there is more than a strain, you fail, you get just genome fragments, but you can compare with your farm reference strain, sort out if there is more than one there present in the sample. So that's the high level guidelines of how to use this tool. And you may ask, well, should I always use next generation sequencing for my farm now? Well, the answer is not really. That's expensive, that costs money, but it comes handy in these times where you have these clinical signs that appear in the farm that you do or 5 and they do not explain, doesn't match exactly what's going on. So in those type of situation, it's a good tool to be used if you have a farm reference strain to compare.
Yeah, so like you kind of mentioned, the key is really getting the full whole genome sequence on the reference strain, right? And then even if you come down the line and use processing fluids and you even just get the contigs or the partial sequence, at least you have something to compare it to that may give you an indication that you either have a recombination or another virus there.
Exactly.
Giovanni, quick question is, you said that one of the uses is to determine how many strains you have in the farm, right? How common have you found multiple strains as opposed to one particular strain moving in the farm?
That's a very good question. We did a work there that was trying to understand how use next generation sequencing, and we followed 20 breeding herds over time that was eliminating PRRS virus. And in 60% of those, there was more than 2 strains present in the herd. 2 strains wild type that. So it's very frequent to detect more than 1 strain in the herds that are circulating. There are situations that are even worse to detect 2 or 3 strains in live virus inoculate the sample that is used for LVI. So those are dangerous because now you are injecting more than 1 strain at the same time in the pig, and those strains have the opportunity to replicate together and do what we call this recombination. That means they swap genes from one to each other, and now they create a fourth or a fifth strain that is going to be circulating in that herd. So it's very frequent to find more than 1 strain circulating there. And one thing that I keep wondering myself is, when you go through a parasite outbreak in a herd, well, will have a lots of wild type strains that is circulating out there. Maybe you're not bringing only one, but could be 1 or 2 strains at that same time that comes into the herd.
Good to have that extra tool, right, for people to understand what's going on in their herd.
Exactly. It's not the tool that answers all the questions, but it provides very good insights of what's going on in these specific scenarios that we talked about of unexpected clinical signs. You are recovering R5 that doesn't make you the clinical signs that you are seeing or heard. Those are the type of situations that comes handy to be used. Plus, additionally, if you have the opportunity to look to your LVI sample before do the virus isolation to see what's in there, that's also a good opportunity to really understand what you're injecting in the animals.
Because the old OR5 sequencing that we've been doing for years, even if you'd have multiple viruses in there, it only amplifies one, the consensus sequence, correct?
Correct. If you look for Ohio State University, the procedure that we do here, there is 4 reads that there is done for that OR5. And then those 4 reads are bring up together to a consensus sequence that is reported. So if there is one that is in very low prevalence inside of the sample, maybe it's one of those 4 reads, but the consensus is not going to pick up that one. So it's a consensus sequence, the OR5.
Yep, new tools, and we're very unique and very happy to have you here. You know, there's lots of labs that can do it, but Giovanni puts it together in a way that is easily explained. That's why we're very fortunate to have him here. That's why we call him the Godfather, right? That's why he's the Don. He does a
Don.
very nice job of explaining all that information. So
I
I
got the nickname now.
So we certainly want to thank him and thank Daniel as well for their excellent and very timely presentations
Love it.
on PRRS as well. Thank you all for attending here today. Next month, we'll have our next series that'll be on December 21st. This time we're actually going to have it over the noon hour at that time. We'll have Dr. Carl Kearns, and he'll be on talking about boar fertility and some of the research that he's doing in that area. So with that, I thank you again for attending and have a wonderful evening.
Thank you.